Hey there, and welcome to the deep dive.
Hey.
Today, we're really digging into two things that are just, well, they're fundamental if you're building anything solid in Ruby on Rails. We're talking database transactions and testing.
Yeah, these aren't just, optional extras. They're really the core pillars that let you trust that your app works correctly and your data stays, well, consistent, especially when things start getting complicated.
Exactly. And we've got the stack of sources you shared articles on designing transactions, understanding how ActiveRecord handles them, a really comprehensive guide to Rails testing.
And even some really useful stuff on dealing with those super annoying database deadlocks.
Yep.
Yeah.
So our mission today is basically to boil all that down for you. Pull out the most important bits. We want you to finish up here with a really clear picture of why transactions are crucial, how to use all the different testing tools Rails offers.
Why it all matters for, reliability and even how you can spot and fix those big headaches like deadlocks.
Think of it as your shortcut, skipping the fluff and getting straight to what you need to feel confident about making your Rails apps truly robust. And why does it matter so much? Honestly, it just comes down to trust, doesn't it?
It really does. Trusting your code, especially when it's touching your data, that's everything.
You need that confidence.
Absolutely. You can't really have a dependable app without solid data integrity. That's where transactions come in. And a good way to prove your code works, which is testing.
Okay, let's dive right in then. Part one, transactions. When we talk about transactions in like a database or Rails context, what are we actually getting at?
Okay, so fundamentally, a database transaction is it's a way to wrap up multiple database operations.
Right.
Think like creating a user, updating their profile, adding an order, wrap them into one single unit of work.
One unit, gotcha.
And the critical idea, the absolute core concept, is atomicity. It's like an atom, invisible. It means it's all or nothing.
All or nothing.
Yeah. Either every single one of those operations inside the bundle succeeds, and the changes are permanently saved. We call that committing the transaction, or if even one tiny part fails for whatever reason, then none of the changes made by any of the operations get saved. The whole thing is undone. It's rolled back to how things were before you even started.
Okay, right. So it prevents that half-done state. Give us that classic example the sources use, the bank transfer one. That really makes it click.
Yeah, it's the perfect example, and it's everywhere in the material for good reason. So imagine moving money from account A to account B.
Okay.
That's really two separate database actions, right? You need to decrease the balance in A and then increase the balance in B.
Right, two updates. Makes sense.
Okay, now picture doing that without a transaction. Step one, you successfully take money out of account A. Great. But then, oops, maybe the server hiccups, network drops, something goes wrong before you can credit account B. Yeah. Oh, is right. Account A is lower, but B never got the money. It just vanished. You've got inconsistent data, lost money, big mess.
Yeah, that's a disaster.
Exactly. And that's what transactions prevent. If you wrap those two steps, debit A, credit B inside a transaction block, and the debit works, but the credit fails, the transaction system sees that failure.
And because it's atomic.
It automatically rolls back the successful debit. Poof. Account A goes back to its original balance. Both accounts are exactly as they were before you tried. Data stays consistent, no lost money.
That example totally nails the why. Okay, so how do we actually do this in Rails with ActiveRecord? What's the code look like?
Rails makes it pretty clean, actually. The most common way you'll see it is ActiveRecord.base.transaction do, and then you put your database operations inside that do.end block. Anything you do to the database inside that block is now part of that single atomic transaction. And Rails handles the commit rollback automatically. If the block runs all the way through without any errors.
Yep, automatically commits, saves everything. But if any kind of exception gets raised inside that block, maybe a validation fails on save, some other Ruby error.
It rolls back.
Instantly rolls back, throws away all the changes from inside that block.
Okay, seems straightforward enough. And the sources mention you don't always have to call it on ActiveRecord base, right? You can call it on a model.
That's right. You can do user.transactionDo, or even some user instance.transactionDo. Functionally, it achieves the same goal of wrapping operations. Using base or the relevant model class is often just clearer when you're working with multiple things.
What if, I'm inside the block and my own logic figures out something's wrong? Not a system error, but say a business rule fails. Can I tell it to roll back?
Yep, absolutely. Rails gives you a specific way to signal that Raise ActiveRecord.rollback.
If you raise that specific exception, Rails will roll back the transaction, but crucially, it won't bubble that exception up further. It just stops the transaction and undoes it. It's like your clean way of saying, nope, cancel this. But remember, any other unhandled exception, like a standard runtime error or whatever, will also trigger a rollback.
Right, and that ties into using those bang methods save.update destroy inside transactions, doesn't it?
Yes, exactly. That's a really key point from the sources. Those bang methods are designed to raise an exception if they fail, like if validation doesn't pass on save.
Okay.
So if you use user.save inside your transaction block and the user is invalid, boom, it raises an exception. The transaction block catches that exception and automatically rolls everything back.
Whereas if you just use user.save,
it would just return false. The transaction would happily continue, potentially committing other changes later, leaving you with inconsistent data unless you manually checked that false return value and raised an error yourself. So yeah, inside transactions, those bang methods are often your best friends for ensuring failures trigger rollbacks.
Gotcha. The sources also briefly mention nested transactions. Is that common?
They exist. You might encounter them if you're dealing with multiple databases. Maybe they use database save points underneath, but honestly, the sources pretty much all caution against them. They can get really complex, behave differently across databases.
So avoid if possible.
Yeah, the strong advice is if you can structure your logic to use a single top-level transaction, do that. Keep it simple.
Okay, makes sense. Transactions are powerful for keeping data safe. But they're not free, right? Are there downsides? Trade-offs?
Definitely. There are performance implications. Transactions require the database to do extra work, track changes, manage locks. It uses more resources. And a really key thing the sources stress is that a transaction holds a database connection open for its entire duration.
And tying up a connection is bad because
database connections are usually a limited pool, right? Especially when your app is busy. So if you put something slow inside your transaction block, like, I don't know, calling an external API that takes ages or doing some heavy computation,
right,
that database connection just sits there, tied up, unavailable for any other web requests that need it. That can become a real performance bottleneck, limiting how many users you can handle.
Okay, that's a huge point. So the takeaway is use transactions, but use them wisely.
Exactly. Only wrap the operations that absolutely must succeed or fail together as one unit to keep your data consistent. Don't just throw them around everything.
Got it. Understand the power, but also the cost.
Precisely.
Yeah,
it's fundamental for robust apps.
Okay, so transactions are our safety net for data integrity. But how do we get confident that our code, including that transaction logic and everything else, is actually doing what we expect?
Testing. That's the other absolutely essential piece.
Right. Let's dive into the testing world in Rails.
Yeah, automated testing in Rails is basically your insurance policy against bugs and regressions. It lets you catch problems super early, way before users see them. It makes your code more reliable over time, and honestly, it just gives you the confidence to change things, to refactor, add features, without worrying you broke something else.
And people talk about TDD, test-driven development.
Right. That's an approach where you actually write the test first, watch it fail, and then write the code to make it pass. It really forces you to think about the requirements up front.
Okay. So Rails gives us a testing setup right away. What does that look like?
Yep. When you create a Rails app, you get a test directory. Inside, you'll find other folders like models, controllers, integration, system, fixtures, a whole structure.
And those are for different kinds of tests.
Exactly. It helps you organize them. And importantly, all these tests run in a special test environment using a separate test database defined in your config database.eml. So you're not messing with your development data.
Clean separation. Good.
Yeah. And there's testhelper.rb file, which is for common setup stuff you need across your tests.
Okay, so what does an actual test file look like inside the structure?
Usually it's a Ruby class that inherits from something like activesupport.testcase. And inside that class, you define individual test methods using test, and then a description of what you're testing.end.
And the TME part is where you run your code and check things.
Yep. You exercise the piece of your application you're testing, and then you use assertions to check the results.
Assertions, those are the key, right? They verify things.
Exactly. Assertions are the core. They're statements that check if something meets your expectations. Menotist, which is the default testing library Rails uses, gives you a bunch of basic ones.
Like checking if two things are equal.
Yeah, like assert a expected value, actual value.
Right.
Or just assert some condition is true. Assert null object checks if something is nil. Assert traces some exception. Checks if the right error gets thrown.
And the sources mentioned adding a message.
Oh yeah, that's a great tip. Most assertions take an optional last argument, a string message. If the assertion fails, that message gets printed. It makes debugging so much easier because you know exactly what check failed and why.
Okay. And Rails adds its own special assertions too. For web stuff.
It does. Lots of helpful ones, like assert difference, article.count, article.create. That checks that running the code inside the block changed the article count by exactly 1. Super useful.
Nice.
Or assert response.success to check for a 200 OK status code from a controller. Or assert directed articles path to make sure a controller action redirected correctly.
Okay, so testing often hits the database. How does Rails keep the test database clean between tests?
Right, that's crucial for reliable tests. We mentioned the separate test database. You need to keep its schema up to date, usually with binrails db.migrate rails messy test, or reset it with binrails test.dd. But the really key thing for isolation between tests is how Rails uses transactions, which brings us back.
Okay, connecting the dots, how does that work?
So this is super important. By default, Rails automatically wraps each individual test method, each test2 block, inside its own database transaction.
Whoa, wait. Each single test runs in a transaction.
Yep. And when that specific test finishes, pass or fail, Rails automatically rolls back that transaction.
Why does it do that?
It's all about isolation. It means any database changes made by test A, creating users, deleting posts, whatever, are completely undone before test B starts. So test B always starts with a clean, predictable database state, usually just based on your fixtures. It prevents tests from interfering with each other.
Okay, that makes a ton of sense for keeping tests independent.
Right.
Does that test level transaction mess with transactions I might have in my application code that I'm trying to test?
Generally, no. They operate at different levels. Your ActiveRecord.base.transaction block inside your application code will still commit or roll back based on its own logic within the test run. The outer test transaction just ensures cleanup after the whole test method is done.
Can you turn that off? The wrapping of each test in a transaction.
You can. On a specific test class, you can set self.useTransactionalTests equal false. But if you do that, you lose the automatic cleanup.
So you have to clean up the database yourself after each test.
Exactly. You'd need to manually delete records or use other strategies. You might need to do this for very specific scenarios, like testing database level locking or certain kinds of background job interactions where the default transaction wrapping gets in the way.
Okay, trade-off between convenience and control.
Got it.
And fixtures. How do they fit into the predictable state?
Right. Fixtures are Rails' built-in way to load some consistent predefined data into your test database before the tests run. They live in test fixtures as YAML files, usually like users.yaml, articles.yaml.
YAML files, how do they look?
Pretty simple. You give each a record a name, like one or administer, and then list its attributes as key-value pairs. You can even link fixtures together, like author.administer in an article fixture to connect it to the user fixture named administer.
Now you can use ERB in them.
You can, yeah, for dynamic stuff like create %, time.current%, though you generally want your test data pretty stable.
And how do I actually use these fixture records in my test code?
Rails makes it super easy. For each fixture file, say articles.eml, it automatically creates a helper method called articles in your tests. So you can just write articles.1 to get the ActiveRecord object for the fixture named one. It's a really convenient way to grab sample data.
Okay, cool. So looking back at that test directory structure, let's quickly run through the kinds of tests you put in each place. We mentioned test models already.
Right, that's for unit tests. Testing your model logic validations, callbacks, scopes, methods, and isolation, usually inheriting from ActiveSupport.testCase.
Test controllers,
Yeah.
functional tests.
Yep, often called functional tests. They test your controller actions. You simulate web requests like get index or post.create params. Then you check the response, the status code, assert response, maybe the HTML rendered, or if it redirected, assert directed juto, or if the flash message is right, or what's in the session.
And test integration. How's that different?
Integration tests look at bigger workflows, often involving multiple controllers or steps. Think of simulating a user journey. You might get the login page, post the login form, follow redirect, then get the dashboard, and maybe post to create something. You use assertions like assertDom or assert select to check the actual HTML content at different stages.
Okay, higher level. And then there's test system. That's the full browser simulation.
Exactly. System tests are end-to-end. They use Capybara to drive a real web browser, or a headless one like Chrome headless via Selenium or Cuprit. You write tests like visit articles path, click on new article, fill in title with My title. Click on Create Article. Assert text article was successfully created.
So you're testing the UI, JavaScript, everything.
Pretty much. It's testing from the user's actual perspective. Great for catching UI bugs or JavaScript issues. You configure the driver, screen size, etc. in application system test case.rb. And the built-in screenshot helper is amazing. It saves a picture of the browser if a test fails, so you see exactly what went wrong.
That sounds incredibly useful. What about views, mailers, jobs?
Yep, Rails has tests for those too. View tests, actionView.testCase, let you test helpers and render templates in isolation, often checking the output with assertdom. Mailer tests, actionMailer.testCase, check that your emails are billed correctly, write recipient, subject, body using assertions like assert mails or assert Kia mail with. And job tests, ActiveJobTestCase, let you test your background jobs. Either we're running them immediately, performing queue jobs, or checking that they got queued correctly, assert and queued with.
Wow. Okay. It's a really complete picture. And if I have common setup, like logging in a user for many tests.
Helpers. You put a reusable methods in testhelper.rb or maybe in files under desk support. A classic is a Signina's user helper to avoid repeating login steps in every functional or system test. Keep things DRY. Don't repeat yourself.
Good practice. Now, running all these tests can take time on big apps. That's where parallel testing helps.
Huge help. Rails has built-in support for running tests in parallel. It can fork multiple processes, the default, or use threads to run tests concurrently, which can massively speed up your test suite, especially on CI servers.
How does it work?
You configure how many workers, processes, or threads you want. Rails splits the tests among them. If you're using processes, it even handles setting up a separate test database for each worker to maintain isolation.
Ah, but wait. Does that interact with the use transactional tests, a false thing we talked about?
Yeah.
Good question. Yes. If you have tests where you specifically disabled transactional tests, maybe because you're testing tricky locking behavior or something that spans processes, those tests might not be suitable for parallel execution using the default database setup, or you might need special handling. The default transactional wrapping generally plays well with parallelization by process, though, because each process gets its own database.
Okay, something to be aware of for complex cases.
Yeah.
Lastly, testing eager loading. Why is that important?
Right. Eager loading is when Rails loads all your application code up front, usually in production for performance. Development and test often use autoloading, load code on demand for faster startup. Sometimes code might accidentally rely on a specific auto-loading order that doesn't happen when eager loading is on. Testing with eager loading enabled, you can turn it on in config environments test.rb, maybe just for CI using an environment variable, or force it with rails.application.eagerload. Helps you catch these potential production bugs before they happen.
Ah, catches subtle loading dependencies. Smart.
Yeah, it prevents nasty surprises in production.
Okay, that is a seriously comprehensive overview of testing in Rails, from the tiny unit tests right up to the full user simulation.
It really is a mature setup. And knowing which test type to use for what job is key to building confidence.
Okay, so quick recap. We use transactions for data safety, and we use all these testing tools to check our code works. But things still go wrong sometimes.
Yeah.
Especially with transactions and multiple users hitting the app at once. Let's talk deadlocks.
Ah, yes, deadlocks. The classic concurrency nightmare in databases.
What is a deadlock, fundamentally?
Okay, basically, it's a situation where two or more database transactions get stuck waiting for each other in a circle. Transaction A has locked resource X and needs resource Y, but transaction B has locked resource Y and needs resource X.
So they're both waiting for the other one to release the resource they need.
Exactly. A is waiting for B, B is waiting for A. Neither can move forward. They're stuck in a deadly embrace, hence deadlock. They'll wait forever or until the database detects the deadlock and kills one of them.
And how does this actually look when it happens in my Rails app? What error do I see?
You'll usually get an error bubbling up from the database adapter layer in ActiveRecord. The sources mention common ones, especially from MySQLDB, like deadlock found when trying to get logged, try restarting transaction, or maybe lock wait timeout exceeded.
Even if I didn't explicitly write code to lock things.
Yeah, because ActiveRecord operations finds, updates, saves often acquire locks on rows or indexes behind the scenes to ensure consistency. If multiple requests do this concurrently in just the wrong order, deadlock.
Okay, so I get that dreaded error. How do I figure out what actually caused it? Which transactions, which resources?
The key tool, highlighted in the sources, especially for MySQL InnoDB, is the command show engine InnoDB status. You run this in your MySQL console right after a deadlock occurs.
What does that tell me?
It gives you a ton of info, but crucially, it usually includes a section detailing the last detected deadlock. It shows the SQL queries that were running in the deadlock transactions, which transaction held which locks, and which locks they were waiting for.
So it really pinpoints the conflicting queries.
Yes. Understanding the lock types helps too, like an X lock is exclusive, locks others. An S lock is shared, allows other readers. Seeing transaction A holds X lock on row R1, waiting for X lock on row R2, while transaction B holds X lock on row R2, waiting for X lock on row R1, makes the deadlock obvious.
That command sounds essential. Okay, so once I know the cause, how do I prevent deadlocks? What are the tips?
Several good strategies came up. Number one, keep your transactions short. The less time you hold locks, the lower the chance of conflict.
Makes sense.
Number two, be really careful with active record callbacks like after create or after save. If those callbacks do more database work, especially things that might lock other rows, they're doing it inside the main save transaction.
Uh-oh. Extending the lock duration.
Exactly. The strong advice is to use after commit for things like that, triggering background jobs, updating complex associations. After commit runs after the main transaction has finished and released its locks.
Ah, smart. Move the work outside the main lock window. What else?
A huge one. Ensure consistency in lock acquisition order. If you have multiple places in your code that might update, say, an order and its order items, make sure they always lock the order first, then the items, or vice versa. Just be consistent. If one part locks order then items and another locks items then order, you're asking for deadlocks under load.
Standardize the order. Got it.
You can also sometimes use queues to serialize access to highly contended resources. And just be aware of your database's isolation level, though changing that has other implications.
That Hacker Noon story you mentioned really illustrated this, right? The real-world case.
Yeah, it was perfect. They had API requests, processing orders colliding with the stored procedure. The API code locked tables A then B. The stored procedure locked B then A. Under concurrency, boom, deadlocks.
And their fix involved changing the lock order.
Yep, they used a temp table in the procedure to change the join order, effectively changing the lock order. They also moved some API processing to a background queue with retries. It shows how understanding that low-level database behavior is key to solving these.
Definitely makes it concrete. It's not just theoretical.
Not at all. Knowing deadlocks can happen, how to diagnose them with show engine inadb status, and how to design your code to avoid them. That's crucial for building apps that are resilient under real-world load.
Wow. Okay, that really was a deep dive then.
Yeah.
We went from the core idea of transactions, that atomic safety net.
How Rails makes them usable with transaction blocks, bang methods, and the trade-offs like connection holding.
Then navigate the whole testing landscape in Rails unit, functional, integration, system tests, fixtures, the crucial role of transactions in test isolation.
Testing mailers, jobs, using helpers, speeding things up with parallel tests, catching those eager loading issues.
And finally, tackle deadlocks. Understanding the cause, using database tools to diagnose, and applying strategies like short transactions, after commit, and consistent lock ordering to prevent them.
Yeah, getting a handle on both transactions for reliability and the different kinds of testing for verification is just fundamental for building Rails apps you can trust and maintain. It gives you that confidence to keep building and changing things.
So hopefully you listening now have a much clearer map of these really essential areas in Rails.
Definitely. And maybe here's a final little thought to chew on, connecting testing and transactions again. We saw Rails cleverly uses transactions to isolate most tests, which is great, right? Keeps things clean.
Yeah, the default behavior.
But we also mentioned that for some really complex tests, like specifically testing deadlock handling or code that manages its own low-level locking or parallel database access, you might need to turn off that default transactional isolation.
Right, use transactional tests equal false.
Exactly. So what does that tell you about testing the really tricky concurrent parts of a system? It often means the standard safety nets and conveniences provided by the testing framework might actually hide the very problems you're trying to find. You sometimes have to step outside the normal patterns, maybe use more specialized tools or manual setup and cleanup to truly verify that kind of complex concurrent behavior. Standard isolation is great until it isolates you from the problem you need to see.